Back, pre-calculus students, we're going to continue looking at our right triangle in trigonometry. When we ask to solve a right triangle, it means to find the measures of all three sides and all three angles. That's what it means to solve a right triangle. We're going to use trig in order to help us do this. For example, we're given a 90-degree angle, and it's saying, hey, find all the other sides, find all the other angles. The first angle is kind of easy. We know that our total has to be 180 degrees for a triangle, minus 90 degrees, minus 30 degrees. Obviously, 90 is coming from this from the indicator of a right angle. 30 degrees they're given to us. This has to be a 60-degree triangle, which is nice because it's a 30, 60, 90. When we're given one of two special triangles, 30, 60, 90, 45, 45, 90, we can find the exact value of our triangle. Just because this problem's kind of a little bit easy, I'm going to kick this 13, and we're going to kick it over here just to make it a touch more complicated. Sorry for those people whose notes you like having nice and neat, but we're going to make it just a bit tougher. Here's how this makes it tougher. We have to remember for 30, 60, 90 that we can come up with exact proportions of our triangles, which means we can figure out the ratios. Opposite of 30 would be b, opposite of 60 is the square root of 3b, and opposite of 90 is 2b. And again, you can check, if you check back to the top of your notes, those where we gave those ratios. So once we set these ratios up, it's all about figuring out what, in this case, the base or our b value is. We know the square root of 3 times b has to equal 13, which means b has to equal 13 divided by the square root of 3. If you want to simplify, or if you're going to rationalize that, that's equal to 13 square roots of 3 over 3. Once we've solved this b value, we can come up with our other two sides pretty quickly. I say this because if 13 square roots of 3 is b, and opposite of 30 is b, that means the side opposite of the 30 length is 13 square roots of 3 over 3. And if opposite the 90 degrees, making this hypotenuse, is 2 times b, that side length will equal 2 times 13 square roots of 3 over 3. When we simplify this, it becomes 26 square roots of 3 over 3. Sometimes, though, when we don't fit into nice triangles, it's not a special right triangle, 45, 45, 90, 30, 60, 90. We kind of have to do things a little bit more differently. We've got to use some approximation with decimals. When we've been given one angle in the 90 degree, we can still come up with this other angle. It's going to be 180 minus 90 minus 23. 180 minus 90 is 90. 90 minus 23 is 67 degrees. 67 degrees is our final angle. And what we're going to do is we're going to say, hey, we've got some trig ratios that we can use in order to help find the other sides. Let's say we want to find this side. I would start with the 23. And I would say, let's call this side, I don't know, x. We're trying to relate what side, what trig ratio relates the sides of the 5 and the x. With respect to this 23, x is the adjacent, 5 is the opposite, and we know that tangents of 23 will relate the adjacent and opposite. Opposite 5 over adjacent x. Multiply by x, divide to get x equals 5 divided by the tangent of 23. We can type this into our calculator. Now, the first thing I will say, if you ever get a goofy answer, if something comes out weird, you don't think it's quite right, hit mode and make sure you're out of radian and into degrees, or into radians and out of degrees. Kind of depends on which one you're given. We're working in degrees, so we're going to stick with it. We're going to hit 5 divided by the tangent of 23. And it comes out to 11.78. At this point, you can use Pythagorean theorem to get an approximation, but I want to set up some more trig. I like trig, so we're going to keep doing that. So now we've got this 5. We want to find the hypotenuse. Let's go down from our 67 angle, just to change it up a little bit, just to add a little spice of life here. Adjacent is going to be, 5 is going to be adjacent. We'll call it h for hypotenuse. Our hypotenuse is going to be always the same, always opposite of 90. So we're thinking what relates adjacent to hypotenuse, that's cosine. So we can say the cosine of 67 equals our adjacent over our hypotenuse. I have no idea why this is happening, but we're good to go still. So 67 equals 5 over our hypotenuse. Multiply and divide to get our hypotenuse equals 5 over the cosine of 67. When we simplify this out in our calculator, 5 divided by the cosine of 67, enter, we come up with 12.80. We've got both angles, we've got both sides, so we've solved the triangle.